Hello and welcome to the MLOps Minute. So that's it, we're almost ready to code. But before we do, let's take a look at the overall vision of the training pipeline we're about to set up. We're about to put in place. So here we go. This is a graph generated by Azure ML. And you can see all the stages in the data and training pipeline. What's happening is that at the input today in production, we have PDFs, and what's going to happen is that we're going to have thousands of flat PDFs that we can retrieve. So it looks a bit like this. We'll have lots of PDFs, each with a unique name, completely flat in a directory. We'll be able to set up an extraction phase, meaning that for each PDF, we'll be able to extract all the images it contains and flatten them for output. What we're going to do is keep the information on the name of the PDF in the output, from which page the image belongs, and if there are several images on a page, we'll keep the index of the image on the page. In our case, there's only one image per page, but there could be several. Once we're out of the box, these images are completely flat. We'll be able to enter a phase of data separation, of data splitting. But to do this, we need the answers, i.e. the source of truth, the annotations. In other words, to know which image corresponds to a cat, a dog, or something else. Just in time, we already have people in production who label these images and tell us that such and such an image corresponds to a dog, a cat, or whatever. We've displayed JSON as output, and as input, it's perfect. With these two data sources, the images plus the labels, we can split the data. In other words, we'll create 3 directories. One called train, i.e. a drive, which will be subdivided into 3 directories, i.e. a cat, dog, another. We'll sort the images. We'll need a second directory called evaluate, which will enable the model to train on these 2 directories, i.e. train and evaluate. And we'll keep one last data set, which we'll call test, which will allow us to validate afterwards that our model has learned well on data it doesn't know. That's all there is to it. Our aim is to achieve this output. And that's what we have at the end of this stage, label split data. Finally, we can train our model. We have as input our 2 directories, evaluate and train. We train our model, which for the moment we transfer to the next step, but we don't version. Now we'll have a model. And with this model, we move on to the test phase. Here it says evaluate, but I'm going to rename it test. The aim is to use the test set to find out if the model works well on data it has never seen. This allows us to validate whether or not we have good statistics and that the model can generalize. If our statistics are satisfactory, what are we going to do? We save our model, we'll version it into a registered model, so it'll really be versioned. We'll also save and version an integration set. In other words, we're going to put aside some integration PDFs that have never been used by either training or practice, not by training at all. The idea is that during this test phase, we'll play with the predictions on all these PDFs or the images to find out what the training has predicted. This will enable us to create this integration set. On the one hand, we'll save the PDFs we can inject into our API, which will deploy as if we were in production with an ISO production API. And we'll have the statistics, i.e. the responses that we've obtained in this test phase. And then the idea will be to validate that we'll have exactly the same responses between training and an ISO production environment. And here's the last one. I don't have the internet anymore, but this is the model versioned in a data set. Here it is. And there you have it, a pipeline that's pretty simple with 4 steps, and that will allow us to train a model, and we'll be happy. Thank you very much, and see you soon for more videos.